To estimate the number of people in Jackson, population 50,000, who have a flu shot, 250 people were polled. Of those polled, 26 had a flu shot. So how many people in the city might we expect to have a flu shot given that kind of comparison? So we're looking at the poll and everyone in town, so total population, let's say. And we want to make a comparison between them. We want to say that those numbers should be in proportion, right? Whatever you get from your sample, you would expect to apply to the population in general. So of those polled, right here, 26 had a flu shot. So 26 had the flu shot out of how many total? 250 that were polled. So we expect that out of 50,000 total population, some number of those, based on this percentage of the poll, would have received a flu shot. So this sets up our two ratios in proportion. We just need to take those cross products. So 250 times x is the same as 26 times 50,000. So 250x is 1,300,000. And then we just need to divide 250 to get x by itself on the left side. So we divide and we find that's 5,200. So does that make sense? If there's a population of 50,000, we expect about 5,200 to have had the flu shot, given that this was the percentage or the proportion from the poll. So what might we expect? We might expect 5,200 to have the flu shot. That would answer the question. If you remember from geometry, if you've had that before, similar triangles have the same shape and the sides are proportional to each other. So in this triangle below, you can see that the bigger triangle here is exactly 3 times the length of each side of the little triangle. So 6 times 3 is 18, 4 times 3 is 12, and 5 times 3 is 15. We can see that from proportions. So like, let's say I compared this side first. So, and I could do it either way. I can do small to large or large to small. I just have to stay consistent. So say I did small to large, that's 6 to 18. And the other side here, that's 4 to 12. And then that last side there, that's 5 to 15. And you'll see that those are all the same. The small is exactly 1/3 of the large, or if you look at it the other way, the large is exactly 3 times as much as the small. So we're going to use that concept to find the length of the missing side of a similar triangle. So here we have similar triangles, and we need to figure out what this length of this side is based on the fact that the sides are proportional. So again, you can do this either way. Say I want to do small to large. Then 9 is to 15, as 12 is to x. That sets up my proportion here. And then I just need to take cross products to solve that. So I'll do 9 times x is equal to 15 times 12. And 15 times 12 is 180. And I just need to divide 9 to get x by itself here on the left side, and that will be 20. So that tells me that this side of this similar triangle should be 20 units. Does that make sense? I mean, this side is longer than this side, so that would definitely make sense here.